Example 5. It says expand that 1 plus x squared to the power of 4 using Pascal's triangle. And it actually tells you how to do it. So do it. Come on. Don't be lazy. So let's rewrite 1 plus x squared. 1 plus x squared equals, so let's rewrite it. What do we end up with?
1 plus x outside.
1 plus. So we're writing our x squared plus x. We're separating that into brackets, yeah? Why? Because this is the same as 1 plus blob, which is where we can use Pythagoras. Use Pascal's triangle, right? And then why are we doing the x squared plus x as 1 plus x? Because it's 1 plus blob as well. So we're splitting it up until we get it into the form that we can just use it on Pascal's triangle. So we end up with 1 outside of, sorry. That should be an x outside of 1 plus x. Close that bracket, close that bracket, close that bracket. All the brackets are closed.
Do you really need a bracket in between the plus and the x?
There? Yes.
Why?
Okay, technically no. You could get rid of that bracket. If we got rid of that, it'd look like that, and that would still work. Yeah. What they're trying to do is say that this whole thing is blob. Cool?
Mm-hmm.
So you don't need the bracket, but the bracket can make it easier just so you recognise that it's blob. But it's your call. I'm going to put it in because I'm a rebel. All right. So now what do we do? Yeah, there it goes. Do it again. I'm going to start over here because that way I can have my hand fully on it. Okay. So what do we got? So we're going to have the 1 plus. Sorry?
4.
Yeah, so we're going to have 4 x1 plus x.
And then 6.
So that's plus 6x squared.
Yes.
1 plus x squared.
Mm-hmm.
Plus 4x cubed. 1 plus x cubed. Plus x to the power of 4. 1 plus x to the power of 4. All good with that?
Mm-hmm.
Now we're expanding it. And you're using Pascal's triangle to do these expansions. Cool?
Yes.
So So those expansions are just using Pascal. So we've worked from the outside in. We've done the blob on the outside, so the 1 plus the x plus x squared, and then we're doing the x outside of the 1 plus x, is what we're doing now. Does that make sense? So we'll have done both expansions. Okay, now we simplify. Well, kind of. 1 plus 4x plus 4x squared plus 6x squared plus 12x cubed plus 6x to the power of 4 plus 4x cubed plus 12x to the power of 4 plus 12x to the power of 5 plus 4x to the power of 6 plus x to the power of 4 plus 4x to the power of 5 plus 6x to the power of 6 plus 4x to the power of 7 plus x to the power of 8. Whew. Now we collect like terms. Gets a bit muddled, doesn't it? Only got the one constant. 4x is the only one, plus 4x plus 10x squared, because you've got that one and that one. And then the cubes, you got 16x cubed. Yep, I'm not going nuts. Then to the power of 4, you've got 6 plus 12 plus 1 would give me 19x to the power of 4. Then I've got 16x to the power of 5. Then I've got 10x to the power of 6. 4x to the power of 7. And x to the power of 8. And you'll notice once again the coefficients are symmetrical. Okay, so that said it was a harder example. What made it harder?
You had to do it twice, there's more times.
Yeah, you had to do it twice. I reckon if you hadn't been given the bit where it says by writing blet and writing blet, would you have been able to do it? Would you have known how to do it?
Probably not.
Probably not. And that's probably where it's at its hardest. So much of this course is the fact that you need to be able to recognise it and go, okay, how can I expand that? What is a mathematical trick I can use so that I can expand it? It's the same as, manipulating things, even with completing a square. The ability to be able to look at it and go, hey, if I complete the square, this will be awesome. The ability to be able to do that will get you a lot further, a lot quicker.